in the last video we started to introduce some of the ways that oxygen and the reactions of oxygen is absorbing the high energy and even the medium energy UV light that's coming from the sun. So we see that in the upper atmosphere, if I'm looking at the atmosphere, there's the upper atmosphere, that's the thermosphere and mesosphere, the stratosphere, and then the troposphere. So we're focusing now on the stratosphere because that's where the ozone is. In the upper atmosphere, all that high energy, we have oxygen and O+, right? Oxygen is being ionized, absorbing the highest energy of the UV. And there's just too much high energy for oxygen to reform to O2. Once we get to the stratosphere, a lot of the highest energy stuff has already been filtered out. So we have a mix of oxygen and O2. So we have some, and importantly, there's a third form of oxygen in the stratosphere, and O3. So we've got oxygen in three forms here. Then, of course, that's going to filter a lot of the UV light in the stratosphere. We get down to the troposphere, and it's nearly all O2. The most stable form of oxygen is O2. So once we've filtered all this stuff out, now the O2 is staying put, and in the troposphere, it's nearly all O2. What we're going to do is we're going to look at this cycle and see how the UV light that's being absorbed is being turned into heat. So we see in the stratosphere, what we actually see is as we go up in the atmosphere, temperature is actually increasing with altitude during the stratosphere. Why? Because we've got some exothermic reactions that are occurring. Okay, so let's look at the reactions of ozone and this ozone cycle. So it's within the stratosphere that the really high energy particles have already been filtered out, but a lot of still very harmful UV rays are coming through, and they're getting absorbed in the stratosphere. Partially by ozone, which is in the atmosphere, getting broken to form O2 and O. I am breaking a bond that is endothermic. The change in potential energy, I'll abbreviate potential energy, PE, is 365 kilojoules per mole. So ozone has a lower potential energy. How do I know? Because I'm breaking the bond, and the energy goes into ripping that bond apart. Energy is coming in to break the bond. UV light is going to break that bond and create, so that energy that it was absorbed by ozone when it broke, that energy must be conserved. It's stored as O2 and O. So this reaction absorbs UV light. For now, it's stored as potential energy. Then, of course, once I've got all this O2 and O, what are they going to do? They're going to reform some more ozone. So we'll get this cycle where ozone is being broken apart and then it's being recreated so it can be broken apart again. What am I doing here? I'm doing just the opposite, right? It's like this reaction written in reverse. So instead of breaking a bond and energy coming in, when I make bonds, that is exothermic, because look at my potential energy. I still have O2 and O with a higher potential energy, and O3 is here, right? The potential energy is just based on the arrangement. So now, though, I'm going from the higher potential to the lower, exothermic. What energy must be released? If I'm coming up here and here, what happens to the energy? It's released, but not as UV light. Now it's being released as a different type of energy, heat, thermal energy, energy of motion of molecules. So what's going on in this layer, the stratosphere? Ozone being broken, and then being broken here, and then ozone being recreated, and then broken again and recreated. And we see this cycle going out. And what the cycle shows is UV light is coming in, heat is coming out. UV light coming in, heat is coming out. And so I've got this UV light being filtered out, generating heat, which is why we see the stratosphere with that temperature increasing at the higher levels. And then as a lot of this UV light is getting filtered out, this reaction doesn't happen as often, and so the temperature drops. So up at the higher levels of the stratosphere, that's where I've got a greater amount of reactions occurring, and therefore a greater amount of exothermic processes happening, and then they filter out. So ozone is filtering out a huge chunk of this, and then oxygen is filtering out the other part. So ozone being created, ozone being torn apart by UV light is one of the cycles. The same though, there still is some high energy light that's energetic enough to break the oxygen apart. This one takes a little bit more energy. So taking that oxygen and ripping it apart separates the oxygens into their less stable state. Let's see, I'm going from this, I'm putting energy in from UV, so therefore my potential energy is increasing. Ripping apart bonds requires energy. In this case, energy is being provided by those UV rays from the sun. That raises my potential energy. Then what's going to happen? They're not going to stay apart. What are they going to do? They're going to find another one, and they're going to reform O2. What happens here? I'm now making a bond. If breaking a bond requires energy, energy is reversible. If I make that same bond, I get that energy back. But it's not going to be a new UV ray. Now what's going to come out, this is an exothermic reaction. Potential energy is decreasing. I'll again abbreviate it PE. Potential energy is decreasing. What happens to that energy? It's released as heat. So in these cycles, for both of them, for ozone and for the oxygen, I'm absorbing UV light. With that UV light, I'm generating heat. And now we can see this cycle, so you can start wherever. I've just doubled a couple of them. Two oxygens are going to combine with O2, and I should put two O2, with O2 to make ozone. That was that first reaction. We said at that point, what am I doing? I'm making a bond. Making a bond. Making a bond is exothermic, so that exothermic process happens. Now I got my ozone. Right away though, what's going to happen in the ozone? UV light comes in and hits it. I'm breaking a bond. Making a bond, exothermic, out comes heat. I'm absorbing energy to break the bond, endothermic, to separate the ozone back out. Then of course, if I got two oxygens, here's the other reaction that's occurring. The two oxygens are going to make O2. That is exothermic, that's heat. Some higher energy UV light still in the stratosphere is going to come in and now break that oxygen back apart. UV light's being absorbed to make O2. And I get all of these reactions occurring, forward reaction, reverse reaction, and I am taking that and shielding out that UV light and blocking that. And in the process, the reverse is also occurring, and so I'm getting heat generated. So the stratosphere does actually, in fact, at the top of the stratosphere where a lot of this is occurring, it's actually a higher temperature than below. And so that is how oxygen is saving us. These are the processes that oxygen is rescuing us and making it so we're not getting bombarded with this stuff. And so thank you, oxygen. This is how it works.